Like, why should we care about sound affecting water structure?
Well, that's where it gets really fascinating because remember, like, our bodies are mostly water.
Right.
Plants are mostly water.
Yeah.
So if sound can influence water structure at a molecular level, could it also be influencing the functioning of these, like, water-based systems?
Whoa, that opens up like a whole new world of possibilities.
It really does.
Yeah.
Yeah, it really does. And to understand those implications, we kind of need to like dig a little deeper into the research.
Okay.
So one study used near-infrared spectroscopy, or NRS,
Okay.
to analyze how water samples changed after being exposed to music.
So back to shining that special light through the water.
Yeah.
Okay, what do they find?
They looked at specific wavelengths of light called absorbance bands that are like particularly sensitive to changes in water structure.
Okay.
And they saw these consistent changes in certain bands after the sound was introduced.
So they found evidence that the sound was like actually changing the way the water molecules were bonding.
That's what it seems like, yeah.
Wow.
For example, they found an increase in absorbance in the region associated with those trapped water molecules we talked about.
Right.
This supports the idea that certain frequencies, like 432 hertz, might promote a more stable, organized water structure.
Interesting. And what about those small water clusters, like the groups of water molecules that are held together by weak bonds?
Right.
Did the sound affect those too?
Yeah, the data suggests that sound, especially at certain frequencies, might actually break up some of these clusters.
Huh.
And this is particularly interesting as small water clusters play like a vital role in various biological processes like cell signaling.
It's amazing to think that sound could have these like cascading effects throughout a living system.
It really is.
Yeah.
It highlights how everything is connected.
Right?
Even these subtle changes at the molecular level can have broader consequences.
Yeah.
Now, besides trapped water and small water clusters, the researchers also studied what's called hydration water.
Right, the water that's like readily available for the body to use.
Exactly. And they found that exposure to 440 hertz music seemed to increase the amount of hydration water.
Interesting. So it seems like 440 hertz might be more like energizing.
Yeah.
While 432 hertz might be more about creating like stability and calm. It's fascinating how different frequencies seem to have these like almost personality-like effects on water.
It's a great way to put it. Yeah, it suggests that like we might be able to use sound intentionally to influence water and the systems that depend on it.
Right.
But it's not just about the water molecules themselves. It's
Right.
also about how they interact with their environment.
What do you mean?
So the researchers also tested the effects of sound on both purified water and mineral water.
Okay.
Water with all sorts of minerals and trace elements dissolved in it.
Did they find any differences?
While both types of water responded to sound, the mineral water, with its dissolved salts and ions, showed a more pronounced change in how the water molecules were interacting with those dissolved substances.
So the sound might actually be enhancing the way water interacts with the things dissolved in it.
Yeah,
That's a pretty big deal.
it is. Think about nutrient absorption, for example.
Right.
If sound can influence how water interacts with nutrients, this could have major implications for how our bodies utilize those nutrients.
Okay, my brain is officially blown. But how do scientists even like analyze all this complex data?
Right, so they use these sophisticated statistical techniques and visualization tools.
Okay.
One key tool is principal component analysis, or PCA.
PCA, what is that?
Imagine taking a giant jumble of data and finding the hidden structure within it.
Okay.
PCA helps researchers identify patterns and see how different factors like sound frequencies relate to changes in water structure.
So they're basically using PCA to connect the dots between the sound and the changes in the water.
Exactly. And the PCA results in this study were pretty compelling.
Okay.
They showed this clear separation between the water samples before and after exposure to sound,
Okay.
confirming that the sound was causing these consistent changes.
Wow.
But it gets even cooler.
Okay.
They also use a tool called aquagrams to visualize these changes.
Aquagrams, what are those?
Think of them as like visual fingerprints of the water's molecular structure.
Okay.
By comparing aquagrams of water before and after sound exposure, researchers could see how the sound was altering those fingerprints.
And did they see any significant changes?
Absolutely. For instance, the aquagrams for water exposed to 432 hertz consistently showed a shift towards more strongly bonded water molecules.
Interesting.
Again, supporting the idea of more structured water.
Right.
And the aquagrams for water exposed to 440 hertz highlighted changes related to hydration water.
Wow, so the visual representation of the data backs up the statistical analysis.
Exactly.
This is all incredible. We're seeing multiple lines of evidence suggesting that sound can actually restructure water in these predictable ways.
Yeah.
But what does all this mean for us? What are the practical implications of this?
That's the question we'll explore next. The possibilities are truly mind-boggling.
Okay, so we've seen like all this evidence that sound can like literally change the structure of water.
Yeah,
But how does that translate into like the real world?
right.
What are the possibilities here?
Well, the potential is huge, like we talked about hydration.
Right.
Imagine athletes using sound therapy to optimize their hydration levels, or people recovering from illness using sound to like support their body's natural healing.
It's like a sonic boost for your body.
Exactly.
What about like applications beyond like our own health?
Sure, there's a lot of interest in how sound might affect plants.
Okay.
Some studies suggest that exposing plants to certain sounds can actually like stimulate growth, increase yields, and even enhance their resistance to pests.
So instead of using pesticides, we could use sound waves to help crops thrive.
Yeah, it's a really fascinating area of research.
That's amazing.
And it aligns with the increasing focus on sustainable agriculture and finding ways to work with nature.
And we talked about singing bowls earlier. What about the idea of using sound for things like meditation or healing? Is there any scientific basis for that?
Well, while a lot of the evidence is anecdotal, the principles of aquaphotomics suggest that the vibrations created by singing bowls can influence the structure of water. And since we're mostly water, it's reasonable to think that those changes could have like an impact on us.
It's like sound creates this ripple effect, starting at the molecular level and like extending outward. This has been like such an incredible deep dive. I feel like my understanding of sound has been completely transformed.
That's great to have. It's a reminder that there's always more to learn and that the world is full of mysteries waiting to be uncovered.
Yeah?
As you go about your day, pay attention to the sounds around you, listen with a new awareness, knowing those vibrations might be influencing the world in ways you never imagined.
That's a perfect note to end on. Thanks for diving in with us.